5. Okay, we gotta find our base gaskets. See them? Jeez. Sharpen a knife last. Oh, you got these new style crappy ones. Not those real good ones like we used to get.
Can't get good shit anymore, can you?
Nope.
Damn.
Keep changing their format material. So this is more of a format material instead of that vulcanized rubber material they had.
Oh, you recommend using them or going to the better ones?
Yeah, well, they have better ones. That's what they got now.
Oh boy. So I'm stuck with those.
You are stuck with them. That's 100% right. Now see, that titty has to go over here. Otherwise you'd be in the wrong spot. Okay, they appear to fit on the motor. That's a good sign. Fits on the cylinder too. Yep. Okay, that's a big plus. Okay, next thing we got to figure out is the nut. Now you tapped all these or what?
Yes.
Did they need it?
Yeah, I added a few more threads on there.
Ooh, those going nice. So is that less than this? A little under 3/4. A little under 3/4. So the thickness of our stainless washer is going to be our, we're going to need to tighten with. So these are little thin stainless AN washers, so they go right there, like that. And that'll give us enough compression height here to actually tighten up the cylinder of the case. These will bottom out up inside the stud because the studs are real tall. And we're not using those real thick triangle spacers that are stock to go in there. Remember them things?
Mm-hmm.
Because they're ugly.
Yeah, they are. Looks is everything.
We need 2 head bolts too. You know where they're at?
Yep. Let me get them.
Nope. We're going to work on your rings. Let's see, these fit. Kind of. If these are tight, we hold them. Definitely not any clearance in there to speak of. So what kind of ring clearance you want?
Whatever you set them at, that you like to set them at.
That's right. Right number?
Yeah.
Good.
That number right there.
Whatever that is. Got an 1/8 of an inch gap in this thing. Look at this thing. Look how big and fat that is.
It's a little excess, all right?
Just a little. That's an oil ring, so it doesn't matter that much. Where'd you get these rings from?
Whoever you ordered them from.
They came with the Pistons.
Well, they're Weisco.
They're actually Hastings, but you know, put these in, you compress them like this and push down. You rotate them around, and you take your piston, square it. You got a gap. and scale fell through. Now you want to know how much clearance that is?
Oh, about, what, 30 seconds?
13 at least. 14 on that side.
Oh.
So at least that much. It's got clearance too.
Do you like that
So if
gap?
this doesn't go in, you have a problem.
Okay, then you gotta grind the end.
Yep.
That looks a little tighter.
And that's a little looser. Big gap.
Oh, okay. I was at the wrong angle. It
Yeah.
looks tighter.
You notice how rough those cylinders look too. See the mirror finish in there.
Yeah, blame it on the person that honed them.
Yeah, I wonder who that was.
The local dealership.
The local speed merchant.
Yeah.
Whoa. Gee. Hey. Look at the gap on that one. Don't even need to look at that. Gee, put two of these in there. That's consistency there. Now, is it light tight? Appears to be. See, look at the ring and make sure there's no gap between the cylinder and the ring. If there's a gap, then you can't use it. The ring's junk. So this ring is extremely loose.
So you're not going to use it?
That's what it came with. What, you want them all to be perfectly tight?
Yeah, just because it came with it doesn't mean I'm going to use it if it ain't right.
Oh. Well, they vary a lot there, as you can tell. See, there's the second ring, so it's got a dimple with it. There's our top ring. This looks like a second ring too, there's the dimple. See, second ring, if you look at it as a taper on the inside.
Mm-hmm.
Top rings do not. See their square section. See that?
Mm-hmm.
The top rings are what matter for making sure they're snug.
That's a compression ring, then, right? The top?
Yeah. See the gap on that one?
Mm-hmm.
Looks halfway decent. That one looks pretty good too. Second rings are not nearly as important as top rings. See, has a lot more gap on that one. You can see how that one's pretty tight. So this ring here is a little undersized. This is like a 5 under bore. That ain't gonna really make any difference in the second ring. What the bore size they got on these? 10 over. So that's a 5 over ring. They give you a 5 over ring.
Mm.
That's why it's so loose. Because you pick up pi times whatever clearance you have. So if it's a 5 over ring, 5 times 3.12 or 32, whatever.
3.14?
And a bunch of the digits after it. So basically 5 times 3 is 15 thou. You got an extra 15 thou on this ring, didn't we? Which
So,
you did. So it's a 5 over ring.
So even though those are 10 over pistons, are going to give you a 5 under ring.
On this one.
Yeah.
And the oil rings. These two are tight.
The compression, but the oil ring's a little
This
looser.
one was tight.
Yeah.
But these oil rings are real loose too. See how loose they are?
Yep.
Here's half a set of tens. tight it is now.
Yep, a lot tighter.
Mm-hmm. So all these are tight. That one's loose though. Oh yeah, true. One was tight, one was loose. I mean. Okay, now I get all rings are all mixed up now. Okay, that has a pretty good gap then. That one's tighter. Let's get a pretty big gap. It's tight. It's real tight. That's a second too. No, that's a top ring. Nope, that's a second. This one here is a top ring. Big ass gap in it. Fairly good, but smaller than that one. About this one. Ooh. Tighter again.
Yep.
Yeah, that was about the same as the last one. Okay. So this is the one that was real loose.
And is that the oil ring, the one that's loose?
No, that's the second ring. See how loose it is? That's our loose ring. This one looked loose, but when you put it in a square, it's tight again. That's why you square them with a piston.
Yeah.
So that looks good. Now if you put a feeler gauge, you can actually check each one and see what they really are. But right now we got 5 rings that are good. So these 2 here are Molly. That one a new Molly. This is an old Molly. Came from that set. And these 2 are cast iron rings. See a different finish to them.
Hmm.
This has the Molly in the dad. This is straight cast. And you want to make sure they get the titty on them. So you know these are definitely second rings.
Mm-hmm.
Titty. Titty. Okay. So this one here is the one that's defective. This is second. So this one here. This is 10 over. This one's 5 over. Let's check our O-rings, rails, to see how tight those are. And they look to be about the same. Similar. I think these are just a hair tighter, but close. Couple thou difference. So that was 5, we think. We got 10 and a lower ring. So you only need half a set of rings of extra. There you go. No problem. Direct bolt on, right?
Yep.
Okay, now is there a front and rear on these?
Yeah, the arrow, right? Doesn't that indicate the exhaust that it points to?
Well, it has an X next to it.
Yeah, so X for exhaust.
If you look at the pocket, this one's smaller than this one. Now, if you want to know if the pistons are identical, you look at the number. See how they both say 4730 P1? That means they're both the same damn thing. And you look at the number on top, that's the same also. So the pistons are identical front to rear. So you can put them in either hole. And I didn't mark them a different for being an F or an R on there, so that means it doesn't matter which hole they go in.
Okay.
They're the same. We got our pin clips here. These are wire lock style. These are the small CW style ones that Wesco used to use. Still do in some pistons. So we have to determine which way we want to put these in. So these are coming in from the right or the left. It's usually coming in from the left because you don't have all this stuff in the way to get the clips in. It's easier. So what you gotta do is you gotta look at the exhaust. Figure out we want this to be on the pin side, on this side here. So I'm going to put the clips on this side, not that side. These go in relatively easily because they're a lot thinner than the big fat Harley ones I use. This is why I tell everybody you gotta wear safety glasses so you don't get poked in your eye and lose your eyes.
Yeah.
Yeah, make sure you do that.
Safety first.
I would never not have my eyeglasses on.
Yeah, they just get in the way, right?
Yep.
They fog up and everything else.
Dirty. Alright, so that's in there. Now if you want to rotate them so that you can get near the clip, you can do that. That way when it comes time to take them off, you just stick your pick in their pocket right on the edge. You can see the edge of the clips right here.
Mm-hmm.
Makes it a little bit easier for the next time. That might be you or it might be another guy. You don't know.
Hopefully it won't be a next time.
It's never ever going to wear out.
That's right. So they don't use those little nylon keepers anymore.
You mean buttons?
Or buttons, yeah, that's what I meant.
Race bikes you can. They do wear a little bit. But most time they don't use them anymore. With a modern way of making a piston, it actually makes the piston heavier to use those. So. Okay, you heard it pop, maybe. I don't know if you heard it or not. I always like to rotate them just to make sure that they're in. And once again, I put it there so you can get to it. So that one's in. So these are a lot thinner than the Harley. I think these are around 52 or something thickness, and Harleys are probably 63 or so. So 10 thou makes a huge difference in the pressure to put them in. The thing about these is, when you have your chamfer on your wrist pin, when it pushes against the clip, it actually expands it into the hole. It makes it even tighter. If you had a pair of spiral locks with a flat edge, it's like a pound. It just keeps beating on like a hammer and it knocks it out. With the wire, every time you hit it, it expands out and it gets tighter, tighter, tighter. And eventually, it will just push the whole side of the piston out, but you know, if you got a problem with your crank being out of true, that's usually what causes wrist pin problems.
Those are a lot easier than those spiral locks.
I use these on my race bikes, and I've never had one come out yet. I reuse them. I reuse the hell out of all those parts. You know, I use the same wrist pin through probably 10 different pistons. Unless it melts the end of the pin off, I can replace it. The hell, clips, I only put one new clip at a time in. And a lot of times I'll put 2 used ones in. I don't care. If the clip is still good, I reuse them. Alright, so we still haven't finished cleaning these yet. That was your job, wasn't it? You forget?
Well, you put them in a solvent tank and
Well, that was the first cleaning. So you scrub pad them with I use a green scrub pad. Now we got to clean off the residue of the solvent and stuff. So we're going to take our CRC and lubricate them. I don't like using water on my nice new raw cylinders because it makes them rust. So I just squirt a little bit of that in there and go ahead and wipe them. comes out brown, it's probably dirty. See, it's clean. So the inside of the bore is pretty clean. So then we take our relatively clean towel, go like that. Run through, see if anything dirty comes off. You know, clean it is now. And then go ahead and do it again. Now you can use brake, clean all kinds of stuff. I just don't like using soapy water because even though it works the best, it rusts the cylinder, so I don't like it for that. Okay, now I flip my towel out inside out, so I get a cleaner surface to work from. And use a spiral action as I'm doing it. See, I rotate my hands to go in. Now reverse when they come out the other way. See, it doesn't get quite as dirty on that side. So there's a clean cylinder. There's a filthy cylinder. See the difference?
Big difference.
It's already broken in. See how smooth it is?
Mm-hmm.
So we don't have to do that 2,000 mile break-in now.
Nah. Start it up and run the hell out of it.
Pretty much. You give it about a 100 mile break-in. You know, if you can force yourself to get like 500 miles, it'd be great. But in the real world, anything over 50 will work.
I'll give it a 100-foot break-in. How's that?
I don't even get that much on my race bike. I warm it up twice if I'm lucky, and then I run it. And you take it apart and rebuild it.
Yep.
You just broke it. Right past broken, just broken. You put a white towel through them, or paper towel, or whatever. Watch out for lint. You don't want lint. Lint is bad. And if you see a bunch of dirt still, clean up some more. Find a clean part of the rag. And that one looks clean now too. Yeah. You can still see the cross hatches in there, just are really fine. So it is low break-in. Pretty much breaks in as you're kicking it through. Alright. It's oily for some reason. What kind of motor oil are we putting in this bike?
What's that?
What kind of motor oil?
Whatever kind you recommend. The kind you sell. What's that? Spectro?
Nope.
Or whatever. Oh, Maxima.
Maxima.
Now, is there a break-in oil you recommend for that?
A Driven, I have that too.
What's that?
Driven.
Driven.
That's the name of it. It's race car oil. I use that too for break-in. Makes the rings break in a little quicker and easier. And the rest of the motor too.
How many miles do you usually run on break-in oil?
Usually go about 300 to 500.
And then just run the 2050 after that?
Then you run a mineral oil of some type to continue the break-in. So I use my Maxima. You can use straight weight or multi-weight. It's up to you what you want to use. This motor with the modern oils, the lifters and the modern oil pump in it, it's like an Evo basically now. You can run 2050. Right? If you had the old style shovelhead pump and crappy lifters and stuff like that, you'd be running 50 weight in it straight.
So I'd use a break-in oil and then a secondary viscosity oil,
A mineral oil.
mineral oil,
That means it came out of the ground.
yeah, not that synthetic shit.
Yep. Get the motor broken in, put 1,000, 1,500 miles on it, whatever you can stand, and then you can flip over to your synthetic or whatever you're after. We got that new Tribodyne stuff, which is pretty good. Try that out. There's lots of different oils out there to play around with, but
I'll use the best on the market, genuine Harley Davidson oil.
yeah. Yep. Sure, that's what they would say.
Well, yeah, they want you to buy their oil.
It's not theirs. It was made by Sun Manufacturing Company up in Atlanta, or Sun Long Beach. That's where they used to get it from. Harley gets their oil made from the cheapest contractor they can get.
And sell it for outrageous prices.
No, not really. It's not that expensive. There's a reason why it's only $6 or $7 a quart. It's cheap.
How much is that Maxima quart going for?
9.
Oh, that's not that much difference.
Travadine's 17. About that. The Driven's up there too. It's up in that range.
Well, what kind of gas would you recommend? Just regular 87 octane?
Not on this motor.
Premium?
Yep, these are high compression pistons you're using. Can't use regular. So we're putting the ringland over here. The spring compressor's right there. Gap. This has a gap here. Then I rotate over here and put the other gap right over here. So I go at 90 degrees apart with the O-ring in the middle.
Yeah, you never want it over the wrist pin then, right?
No. You don't want it on the thrust faces, you don't want a wrist pins, you want the ring gaps on the 45s.
Yeah.
So you can put the O-rings 180 apart if you want, but 90 is adequate on those. Okay, then you have the second ring to deal with. That'll be the one with the titty hole, the dimple. Now these, do not twist them like the O-rings went on. Don't do that. It screws the ring up. So you take it, you push with your fingers here, and you open it with your thumb and push down on it. And you start with it in the ring groove you want to be on. See, I'm in the second ring line. Expand with your thumb and push it down with your four fingers here. See, it's in the ring groove right here. You don't want to be twisting the ring because it screws them up. And once it goes over the top point right there, you can just use your thumbs to go like that. It'll pop in. And the ring should be free in the groove. If there's any binding, you have a problem. And that's what happens when you twist them on.
When you spring it, yeah.
It's like a big wave washer. Now it's tight. Yeah. It also flexes it so it doesn't seal correctly. So this one doesn't matter how it goes. You always want to make sure it's rectangular cross section up here, then you know it doesn't matter. If there's any kind of marking on it, then you definitely put that up, but on Hastings there's no difference. This one you do it the same way. Put it in the top ring land this time instead of second. Spread it out a little bit. Get it to where it just goes over the top. Once you're over the top, it's equal pressure with your thumbs and it pops down. Same thing, you make sure it's nice and free. Then you find your ring land wherever it was. It's over here. So I'll put the second ring there, and the top ring I put 180 over. Right over there. Make sure they're all free. Good to go. So this one's the second.
The trick is to do that without puncturing your thumbs.
Unused rings are sharp, they actually cut into your thumb, but these ones aren't too bad. See, there's not that much of a gap. Even though these are brand new and they feel sharp, they're not as sharp as ones that are worn in. Those are like knives. There you go. Make sure it's in there free, see? Nice and free. If you have a twist in your ring, take it out a little bit so it doesn't have the twist. But it shouldn't be twisted if you did it right. It's only going to be twisted if you did it wrong.
Yeah.
And if you overspread it, you can break one. It'd be pretty hard to overspread them with your thumbs though. The other one, if you use a tool over here, that's my ring expander. It's a Blackhawk.
After a while, you get to the point where you don't need it.
On used ones, I use them. And some real heavy rings, you gotta use them too. When they're 16th rings, you don't have to use them, but when you got the 5/32 rings, the big fat ones that cars use, you need them. Or diesel rings. Them things are like a 1/4 inch thick. Those are hard on your thumb. Squeezing them all day long, it doesn't move. Okay, now I lubricate the piston hole. See, I cut you
Yeah. Sharp edge right there.
just a little bit. So don't keep going when it does that, it hurts.
Then you won't be able to tell the blood from the assembly lube.
I've had that issue before, yes. So don't be too quick on turning your finger in that hole. It might be biting back. So you want to make sure the whole hole's lubed all the way through. Just get oil all the way through. Now you don't have to oil the rings at all. The cylinder's got lube. See the oil in the cylinder? When you shove the ring through that cylinder, it lubricates the whole cylinder top to bottom, and it lubricates the rings too. If you flood the rings with oil, sometimes they don't seal very well. The biggest thing is when you got that much oil in your cylinder, when you go to start the bike, that oil comes up and fouls the spark plug because you got too damn much oil in there.
So you got to find the right amount to.
Less is better at
Yeah.
that point. Okay, now I like to put the pistons in the cylinders how I like to do it. It's best to put the gasket on first. These don't require sealer because they got a silicone spray or something, or some kind of plasticized crap on the gasket. It makes it work better.
You know, had I thought about it before I painted the cylinders, I would have had you put the little lip on the other part so the gasket seals better. You know, the head gasket. Like,
Oh, you mean
like
put the compression up in there?
yeah, but that's right.
Compression groove. Okay, so this is our front cylinder. This is our rear cylinder. This is the left side. This is the right side. The drain back hole is the left, if you didn't know. Okay, this is laid out as being our front piston because that's how we had it originally. Things have been moved around though, it looks like. Nope. Reversed. Okay, there's a clip. Exhaust clip. So this is the right side. This is the front. This is the front part of the motor. So this goes over here. Flip it over. Drop it in. So the wrist pin goes in through this side. See, there's no clip. Clip. So that's how you know. Now, my ring compressor is, put this part in first. Push down on that side and squeeze this part. And it pops in most of the way. See how it's almost all in already? Then you lightly tap it with your hammer. It's in. That was a hard hit. It was like that much. You gotta go boom like that. Oh, that's probably too much to use.
You break the ring.
Okay, now you go over here and do the same thing here. You push this side in, cock the piston up slightly, get it to drop in. Don't want to go in though. Yeah, really held up on. There you go. Nope, it's not in there yet. See, that thing's just fighting me today. There it goes. Okay, see now the ring's out like that, just pushing in. See how the piston just kind of drops down the hole. Make sure you get this cut out in here. Squeeze it in a little bit more. Right now we're caught right here in this corner. So you squeeze it a little bit with your fingernail. If that doesn't work, you get your the flat side of the blade that's dull. Lay it on the ring. Just push it in a little bit. And just lightly tap it around in a circle until it goes in. See, it's like putting a shoe on. Now there's our one ring gap. The other ring gap is right here. Put that over there. Push that in. Go over here. Push it in with your thumb. Tap it down. See, we're hitting right here right now. So you go over on this side. See, it went right in. If it gets tight one way, go on the other side. Come around the other way. See Okay, now this one here went in on this side, so bring it up a little bit so it's out. Go back over here. Get that side in. It's cleared already there. Tap, 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 tap. Then
Just like downtown.
and you beat up a little bit to get the pin to clear. Like this. And there you go. Center it up. And make sure you put it on correctly. So, just push rod side. And exhaust should be toward the front, which is that way. Is that where it is?
Yep.
And you did it right. It helps to always check. See the top one already went in. I don't have very many nails right now, they're all broken off, so makes it a little harder to do this.
You gotta quit biting your nails.
Yeah, that must have been it. It was all the nerves of getting your motor together.
Yeah.
See, right there,
And it still ain't
stuck over-
together.
See, we're stuck over here right now, see? Where's our gap at? You don't see the gap. There it is, right there. Boom. So you always get the gap first, then you look for your cutout, and you just tap it around. See, you're pressing that spring the whole time.
Mm-hmm.
You see we're stuck on that because this is already in. Pull that out. See, it went right in. We want to get over here first because we want to make sure it gets around here. When you hit this edge right here, that's where you're going to bend the ring and screw it up. It goes in hard, like it's not going right now. Around the back side. Work around. Boom. No fancy ring compressors needed.
That's just for amateurs.
These new twin cam bikes with super short ass pistons, you need them, but on a regular bike you don't need them.
Who wants a twin cam?
Not me.
Me either. Sorry, all you twin cam owners out there,
I
but
want something I can drive fast and not break. Alright, what are we going to do for oil? Being oil? You going to get braking oil?
yeah.
Got some gear oil over here, put that in there.
Yeah, put some 3-in-1.
Fork oil. Alright, you want braking oil?
Yep.
Alright, braking oil. $15.50, that's really light. I wish this was $20.50, but
Hmm.
Maximum only makes $10.40. That's why I don't use theirs, or $10.30 or some stupid number like that.
Well, which one would you recommend for me to use for braking? That
I'm
one?
using this one because it's the thickest one I can get. That's
Oh,
good.
okay. BR.
I don't want to use that thin ass crap. See, this is racing oil, conventional brake-in oil.
Okay.
I don't know what unconventional oil would be. We're not going to use any of that unconventional stuff.
I can use that Harley oil.
Yeah, you can use that all you want. Okay, now I take this and I pour it on top of the rod set and try not to hit the gasket surface. Let me just pour a little bit in there, kind of working it a little bit. That's enough. Put about, I don't know, a third of that in there, half of it. And work the oil in a little bit. Make sure the rod's really getting wet. I always want to make sure that the flywheels have oil on them. See how it's down in the oil?
Mm-hmm.
So that way, as soon as this thing is spinning over, it's slamming, it's putting oil up on your piston skirts. As soon as it turns. So that's what you want to, that's why you put oil in here first. Okay, so this is done with this. So the rest of this you can put in your tank. And then probably a couple more quarts on top of it when you hurt.
Yeah, it's a 4-quart tank, I believe. So.
And then 2 quarts is enough to get in there running on, started. You can break the whole motor with only 3 quarts in there. You're not going to be getting it that hot when you're breaking it in.
Mm.
At least you shouldn't be. Save some money.
Yeah.
Take and lubricated that. I like to lubricate my stud holes here, stud threads, whatever. So I use my nice thick oil here for lubrication purposes. Gives you a little bit better torque. It makes it messy when you screw up and put it together too. It's a plus.
Now, how soon do you got to retorque the heads and the barrels?
After it cools off a little bit, a couple times.
And then after that, is there any miles again to retorque them?
Whenever you think about it. If they're not moving, you don't have to keep doing it. But if they keep moving, keep tightening them.
Mm-hmm.
You know, whenever you do your oil change, it wouldn't hurt to check all your hardware on your bike.
Okay.
I'm sure everybody does that, don't
Oh yeah.
they?
Yeah, everybody does that.
Okay, stick this in here. Find the wrist pin hole. There it is. Wiggle it around a little bit. Push in with your finger. Let it hang. Take your rag. That's not very clean. This one's kind of clean.
Okay, I want you to be honest with me. Have you ever dropped a clip down in the case and had to split them to retrieve it?
To split it? No. To retrieve, yes.
You lucked out then.
Well, if the motor's like this, you can get stuff out. That's when the
Yeah,
bike's
but-
together, you have a problem. So, same deal. You put the clip in here. It's just like the rings. You stick it in there, and you wrap it around a little bit. Now these you wrap. So you're just going to compress it in a little bit at a time. I'm pushing it with my thumb. Right now I lost the edge there because I couldn't get to it. You got this big lip right here which keeps you from coming that direction. So I'm going to go the other direction. So, see, I'm pushing my thumb over here, pushing in. Let the screwdriver do the work, at least try to. Get on the clip if I can. There it goes. Gotta push it around. Once I get to that point there, see it's almost all in now. Push it around. Pops in real quick and easy, see. Okay, now you come back and you make sure it'll rotate a little bit. If it'll move, that means it's not dug in, it's probably in the groove. So now it's in the groove. Okay. And you take your oil, you lubricate your skirt. You don't have to lubricate the whole side of the piston because it doesn't touch the cylinder anyway. Only have to worry about your thrust face. And the back of the motor is the heavy part. It needs it the most, not the front. Okay, now we're just going to drop this down. Get your gasket started. Get the cylinder started. Just kind of wiggle the cylinder back and forth, and as the rings move, you can drop a little bit at a time. Down. And you pull your rod back up. See, with a smooth bore, you can pull the motor back up pretty easy. Okay, now it's time to put your hardware on here. Now we need your head bolts. Where's your head bolts at?
They're over there, straight ahead. The box right there by the funnel. Right there.
We're using Gardner's.
Gardner Westcott.
That's what we're using today. Okay, these have to, two of them have to go in right now.
Otherwise, you'll never get them in. Right.
Not full length anymore. Now, Colony, S&S, and Gardner Westcott all make head bolts. And every one's different. They all make 12.1s. S&S has the thinnest washer. Colony has the next thinnest washer. And Gardner Westcott has the thickest washer, the whitest. Now with a stock cylinder, you have plenty of room for a thick washer like this. See that? See how it fits in there?
Mm-hmm.
No problem. See how it goes a little bit extra than what you need?
Mm-hmm.
So if it goes extra a little bit, you know you got good. Now on a big bore cylinder, you don't have room for these. These don't fit. So these only work with stock cylinders. So you gotta make sure you get the right hardware for the right application. Now, you cannot put the rear exhaust bolt in right here because the stud's in the way. On an 80-inch motor. On a 74-inch motor, it can go in
Okay.
because the stud's a 1/4 inch shorter.
Hmm.
So only on these 80-inch motors,
You got to put that in.
or these long studs, you have to have the bolts in now. So this being a later motor, we have to put it in now. Now, same thing we gotta do before, we'll make sure you got oil in this, because you're not gonna be able to get to it later on. And make sure it's got a good squirting of oil on there. Stick it up in there. That's it. Bring her up a little bit. Oh, it fits. Then we take our handy dandy
Bolt holder.
crane cam retention tool.
Yeah.
Really knows the close down. Put that in there.
I think Jim's starting to make them too now.
They got their own special factory over there in China.
Yep. Bamboo.
Cranes are actually made out of plastic. Okay, put your washer on there. Put your nut in here right now. You got access to do it. Now you got to do the same thing over here because the fin's in the way. And you want these skate core nuts or cap nuts, so you don't have the room. So if it goes all the way down, this won't fit. So you got to get all of these started right now. And you want to make sure you don't drop the washer in there, especially the stainless ones.
Because you can't get it with a magnet.
Now the nut you can get back out. I've lost the nuts a few times because you go to start them.
Have you ever dropped a stainless washer in there?
Yes, I've dropped them too, and you have to go hunting for them.
Yeah.
A lot of times you're lucky you get in there, you go in there with a little piece of welding rod or something.
Yeah.
Or, you got a little hook on it or something. Yeah, a lot of times you think they got these started, you go to spin them and they swing across the room. See, you go like that, and whoop, it goes right in the hole.
You must have a lot of horror stories you can relate to.
Yeah, well, I've done a couple.
It's all part of the business.
Okay, you go down a little bit, and you pull them all down a little bit. Sounds like I'm hitting on this one. Yeah, it is. See, I was hitting on the bottom of the fin right there.
Yep.
You pull up on it a little bit and get it out of the way. All the way down now. Now this one you don't have to worry about, there's no fins here. You can actually put this on whenever you feel like it. Okay. Now once you're done, you take the cylinder and you rotate it inward toward the intake. See, I get this gap in here?
Hmm.
See that clearance?
Mm-hmm.
So you want to pull it, turn it counterclockwise. That way the intake port up here gets closer together, your
okay.
manifold fits better. See, there's always a reason for this stuff. Now, you notice how this wrench has been trimmed, but not height, side to side.
And is there ever a time when even then it's all tight, you still got to loosen it and tweak it when you start putting the manifold on?
Yep. Okay, see how this one fits in there still? So you got to kind of roll it in there. Now the acorn nut gives you a little more room to roll it. That's why I liked it better. The cap nut's a little bit flatter on top, so it's a little bit harder to get the wrench in there. So this is my heavy duty wrench. This is my light duty wrench. This is a different one. I used to have one that was cut down thinner, about only that deep. It breaks after a while. But this one's cut thinner than this one. Do you feel that thinner on the OD? This one gets in a tighter place as easier. This one's actually dragging on the paint a little bit. You had that thick layer of paint in there. So this one is not dragging all the way. Okay, so that one's in there. Like I said, see how freely it moves. Try that with your 220 grit cylinder finish motor.
Here, like, you hold it.
To push down a little bit. I'll pull up. It comes over relatively easily.
Yeah.
So that's why you get a good cylinder finish. Now my race bike, it just drops right through. You can spin that thing right through, no problem. It has even a finer finish and lighter tension rings. So it spins over real free.
Well, yeah, you
Yeah.
build your motors loose on your race bike.
Well, they're not, no, it's not loose. It's 2 3/4 thou when it's brand new on top fuel motor, which is like half what you normally use. When you're bore limited, you do what you gotta do. Now you got the wrist pin right here, so you can stick it through a little bit if you want. You just kind of put it in there, kind of wiggle around, put a little tension on the pin here. You can hear it drop in, and just push it right in. Now if I didn't pre-fit to make sure the pin went in there easy, you have to beat that in with a hammer, which can screw the pin up in the piston going sideways. Also, when it hits the pin bushing in the rod, it puts a big burr on that, locks up that, and if you keep beating on it, you can
You
run
could
the rod
tweak the
over
rod,
it.
yeah.
And so it's best if you don't have to do any of that crap. Plus a real race motor or heavy duty street motor, you want the pins to float so they don't bind up anyway, so there's no reason to be that tight. There's no performance mileage advantage of being loose, being tight like that. Okay, now you put this one in there. See I dropped it in? See I just kind of twisted my fingers and I already got it in there halfway? With a light duty clip like this, you can do that. Even with my left hand, which I don't have much skill with, I can still put it in here. See? Pretty good, huh?
Yep.
Okay, there's the clip. I can't see it, but I know where it is. There it is right there. See, it moves. Make sure you're in there. Now you want to make sure that your end play is not super loose. But see how loose they make these? In the real world, it should be a third of that. The more clearance you got for the pin to ram into the pin, the more it can ram into it. You know, it's production. They don't do anything really good. Just okay. Now, you notice I didn't forget to put the gasket on. I've done that.
Have you ever gotten lazy and just cut the gasket in half and stuck it on there?
No.
I know, I'm just messing with you.
Uh-oh, see that one fell in. So just stick it in the hole now. Make sure the sleeve is in the bore. And you tap a little bit as you jiggle it. So the key is do a lot of little things, don't beat the hell out of it. Okay, here's a washer, nut, nut, another washer, another nut. Got a lot of nuts on this job.
8 of them.
Yeah. And don't forget we need to put our bolt on the
Yeah.
exhaust side, because the exhaust pipes are right here. That's why you call it exhaust. Now, unlike a modern motor like an Evo or a stupid twin cam, we don't have to worry about our base gaskets leaking very much because we got big nuts here to hold them down. They don't go stretching up and down all the time. That 7/16 stud puts a lot of holding power on that gasket. So those big long skinny 3/8 bolts that are supposed to do everything, they don't have half the holding power this 7/16 bolt does. Okay, so now we're going to start it. Go down a little bit. See, I went too far, so you hit the stud. Spin. Pull up a little bit. More. Damn it. Well, that one just got tight, period. These ones are free. Thought you went over all these bolts.
I did.
Is that the new one that you didn't do?
I did them all.
You did them all. Why is this one not going?
Take it out and look at it.
Did you drop the cases on the floor and screw up the toilet there? Or?
It could have been.
That might have been what we did.
Yeah.
That's a 5/8, that doesn't work. See? You let the customer do some work, and look what happens. See, it's tight.
And Tatro's got to do the rework.
Look at that. That's like a lock nut now. You sure you tapped that? I don't think you tapped this one.
Yeah, because I tapped it here and it stopped.
Must have used my tap then. Did you use my worn out tap?
No, I think it was mine.
Your worn out tap.
Yeah. Because I lost a nut,
Yep.
and then I took one out of the package and I tapped it right here.
One of these is not happy with going down.
And that's that one there.
Yes, it is. Now, if it was much tighter than this, I would have to
Chase it then.
take it back apart. You're starting to get some pretty good tension on that, just to move it. We're not even up to torquing anything yet. Because you gotta remember, the drag on the stud, you have to take that off of how much torque you're doing. So if you got 20 pounds of drag to tighten the nut down onto the stud, to actually tighten, you're gonna have your 30 foot-pounds of torque, or 40, I like using her better, and add your 20 to that, and you get 60 to 70 foot-pounds you gotta use now. That's what the problem is. Okay, now this one here. Okay, we had that same rock back and forth, see?
Mm-hmm.
So this time we do, this one we turn counterclockwise, this one here we turn clockwise, because you want to rotate it toward the inside. So you just put tension on it, the thumb here rotating that way, and you go ahead and tighten the nut down, right there.
Does that got to be rechased?
What?
That nut right there?
No, I just move it, just tighten it.
Okay.
We're just going to make sure it's tight. When
I think you screwed up the thread when you bead blasted. I'm going to blame it on that.
Okay, I think it's when he dropped on the workbench 15 times. This steel bench is going to destroy that stuff. I've had a lot of complaints about steel bench hurting products.
Yeah.
They want a nice wood top on there or something. That makes a lot of powder and crap that goes in the motor.
Yeah.
They don't care about that though.
You know, all these wooden splinters in there. And
Yeah. See, a steel bench doesn't put any metal in your motor when you put it together. Okay, how much torque do you want?
whatever you require. I don't.
Whatever I require.
What do you do, about 30 foot-pounds?
I require a lot.
Well,
Well, I can only get so much with this stupid bench steel here, so
why don't you get out the old torque wrench and
not that much. Not that much. About that much. This one feels soft for some reason. That one must be tight already. See, nothing over here to grab a hold of it. The oil pump is smooth.
well, I can hold the motor if you want to get the torque wrench out and torque it down.
I'm torquing it right now. This is your official torquing.
Got an internal click in your brain when you hear it click, and you know proper settings in.
It's tight. Now after it's in the bike, you can torque it some more if you want.
Well, I'll do that after I start it up too.
Okay, now you want to make sure the motor turns over and does not go tag on the pistons. There, I went that far by hand. We got to pull out the tools now. Now you could just throw your motor sprocket down here, bottom it out, and use that to turn the motor over too. In this case, we're going to use this tool. Now, if you turn the motor over backwards, the oil stays in the crankcase. When you go to start it, it's there. Now, if you keep putting this motor over clockwise, like it normally rotates, the oil goes from here over to here and it collects over here, and there's no oil in here to help lubricate the motor. So when you're working your motor, always ready to turn it backwards. Because then the oil will stay right where it belongs. It appears that somebody over lubricated the rear hole. See how much oil's in there? Got way too much oil in there.
Yeah, it's a factory assembly line.
See, the front one's more correct. It's got just a little bit in there, and that's it. So you already see how the rings are scratched and the piss out of the cylinder? Those are all the sharp edges on those rings. Because you didn't deburr them.
Here's you burn them now.
They're almost broken in already.
Yeah.
Now you want to know how much drag it takes to turn it over? Not much. How many foot-pounds of torque is that? Okay, I keep the motor up here is where I keep it. That way you got less chance of collecting crap in here. Okay, now you're ready to put your top end on there, your heads. Which we haven't finished yet, so we're not doing them.
Yeah, the heads aren't ready.
Yeah, that's right. We're going to put our clothespins away, because we might need them for an important job. Alright, so this is it for now. So later we'll go ahead and get the heads buttoned up. We still got to do some more work on them yet. But anyway, that's how you do your cylinders, put them on and pre-adjust them. Now if we have to move them again to adjust a manifold fit, then you have to break the gasket free. Now these gaskets aren't going to do much damage when you break them free. If you had gasket cinch on there and you break them free, you broke the seal. So it's best not to take your cylinders and try to move them after it's together. Sometimes you have to, but it's best if you don't.
Well, we'll find out when you put the manifold on.
Yeah, this one here, if we had to, it's not going to kill it too bad, but I really don't like moving once I put them on.
Yeah.
But anyway, that's where we're at, so that's how you do that part. We'll just wait for our heads to be done.
All right, signing out.
All right.